Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing each and every chapter concept wise. Then we are also solving all the past 10 years questions from that chapter. So today I am going to discuss the previous year questions from ray optics and optical instrument. Also, every Sunday we are doing KPL, KCET Premier League. So if you are targeting for KCET 2025, this is a must have for all of you. It is absolutely free of cost. So what are you waiting for? Only thing that you have to do is join our WhatsApp channel, and there you will get all the updates related to KPL, related to whenever we are posting a video, you will get the notification and all the updates. Now let's start with today's topic, that is ray optics and optical instrument previous year questions. So first question: for a given pair of transparent media, the critical angle for which color is maximum? Very interesting question. So we know that the critical angle sine, say theta c. Critical angle means at the angle of incidence where the light ray passes between the medium separating the plane separating the two media, right? So sine theta c is proportional to 1 by refractive index, right? So refractive index again is inversely proportional to wavelength. So what we can write is sine theta c is basically proportional to wavelength, right? So two negatives become positive, so two inversely proportional becomes directly proportional, right? So theta c basically directly proportional to lambda. So if lambda increases, the theta c will increase. So for which angle it will be maximum? We know that lambda is maximum for red light. In the previous chapter, electromagnetic waves, we have learned that lambda is maximum for red light. So for red light it will be maximum for the critical angle will be maximum for red light. Now let's move on. An equiconvex lens made of glass of refractive index 3/2 has focal length f in air. It's completely immersed in water of refractive index 4/3. The percentage change in the focal length is. So first of all, what was the formula for focal length? It will be, this question is based on the lens maker's formula. So we know that lens maker's formula 1 by f equals to n minus 1 by r1 minus 1 by r2. Okay, now for equiconvex lens, r1 equals to minus r2 or r2 equals to minus r1, whatever way you like to write. Okay, what I will do, instead of writing r1 and r2, I will put the values. Suppose r1 is r, then r2 will be minus r. Okay, this is simple. So if you put these values, you will get n minus 1 by r minus 1 by minus r. You remember this. This will be very helpful in future problems as well. So n minus 1 2 by r. This is the focal length. Now for first case is air. So f air is nothing but 3/2 minus 1 times 2 by r. Not f air, 1 by f air. Sorry. It will be 1 by f air, or equals to 1/2 times 2 by r, or equals to 1 by r. So f air equals to r. Okay, so this is the relationship. Okay, now when the entire system is now immersed in water, now what will be the refractive index? The refractive index n21 is n2 final refractive index by the medium outside. So in this case, final refractive index is 3/2. The medium outside has water, so it will be 4/3. So it will become 9/8. 9/8 will be the refractive index. So f water will be equals to 9/8 minus 1 times 2 by r. 2 by r will remain the same. right? So 1 by 8 times 2 by r, so it will be 1 by 4r. So F water is 4r. Okay, now how much increase? Delta F. Delta F is the difference in focal length. So difference in focal length is 3r. So 300% increase. 300% increase. So 300% increase is the correct answer. Right. Now let's move on. A point object is moving at a constant speed of 1 meter per second along the principal axis of a convex lens. The focal length is 10 centimeter. The speed of the image is also 1.1 meter per second when the object is at a dash centimeter from the optic center of the lens. Now we know that when the object distance is 2f, image distance will also be 2f, right? When the object is placed at a distance 2f from the lens, then the image will also be formed at 2f from the lens, but in the opposite side. And they have asked you the speed of the image is to 1 meter per second and speed of the object is 1 meter per second, then at which position this will be achieved. So only at 2f this is possible, right? So when the object distance is equal to image distance, so basically the speed between which they are moving is actually dependent on the ratio of their distances as well. So from there you can derive it. There is a derivation, complex derivation given in some books, but this is a simple KCET question, so don't need to do the complex calculations. Simple logic that you have to apply is that when the object distance is equal to image distance, then only both of them should have the same speed. Now object distance and image distance are equal only at 2f. So focal length is 10 centimeter. So the image distance or object distance, whatever it will be 2 times 10, that is 20 centimeter. Okay, so 20 centimeter is the answer. No need to think, just think that it should be happening only at 2f because the both speeds are equal. Okay, now for a point object, which of the following always produces a virtual image in air? I think I have discussed it. So only convex mirror always produces a virtual image. Plano-convex lens can produce real image. Biconvex lens always produce, not always, but it produces real image. Concave mirror also produces real image, but convex mirror, they always produce virtual image of real object. There are certain cases they can also produce a real image, but that is virtual objects. Okay, for virtual objects they can produce real images, but that we do not consider when we are considering the image formation, right? Now let's move on. Consider a glass slab which is silvered at one side and other side is transparent. Given the refractive index of the glass slab to be 1.5, if a ray of light is incident at an angle 45 degrees on the transparent side and after reflection the deviation, find the angle of deviation of ray of light from its initial path when it comes out of the slab. Now I discussed this problem. We know that angle of deviation in case of reflection, angle of deviation in case of reflection is nothing but 180 degrees minus 2i. Okay, you don't need to consider whether there is a glass slab, there is a mirror or whatever it is. As long as it's reflection, we can simply use this formula. So 180 degrees minus 90 degrees, that is 90 degrees. Okay, so angle of deviation is 90 degrees. So correct option is option B, right? Now let's move on. Focal length of a convex lens will be maximum for. So focal length of a convex lens, we know that focal length of a convex lens, they have given some colors, so we have to find the relationship with the wavelength again. So we know that from lens maker's formula, wavelength is n minus 1 by r1 minus 1 by r2. Right now r1 r2 are generally constant for a lens. Only thing that is can be changed is the refractive index. So we know that refractive index and wavelength are inversely proportional, so we can write that 1 by f is inversely proportional to 1 by lambda. Okay, there is a minus 1, but for now we are ignoring that. So focal length is directly proportional to lambda, right? So if the lambda increases, focal length will be more. So again red light. Okay, so red light will be the answer in this case also. So previous two questions that we have seen, they are asking questions based on the mutual relationship between refractive index and wavelength. Again, so there are a second quantity involved. So if you know the relationship between refractive index and wavelength, then you can solve all such questions. Okay, be careful next time, and if you see such questions, don't mark blindly red light. Maybe they will ask you a different question, different form, where maybe by violet light or blue light will be the answer. So be careful before answering. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to the angle of emergence, and each of these angle is equal to 3/4 of the angle of prism. The angle of deviation is, okay. So first of all, what they have said, that we have a prism through which light enters, and after the refraction, angle of emergence and angle of incidence are same. So I equals to E. Now when does that happen? So I equals to E only at the angle of minimum deviation, right? So this itself is the angle of minimum deviation. Also, they have mentioned that this is an equilateral glass prism. So basically, equilateral glass prism means if you take a cross section, that will be a equilateral triangle. Now what is the angle for an equilateral triangle? Tell me the answer. Yes, equilateral triangle, the angles are all 60 degrees, right? All angles are equal, and we know that total angle in a triangle is 180 degrees. So all angles are equal means each of them should be only 60 degrees, right? So A is equals to 60 degrees. From this information we can write A is equals to 60 degrees. So all the angles are given. I equals to E equals to 3/4 of A. So 3/4 of 60 degrees, 4 15s are 60, so it will be 45 degrees, right? So now we know that angle of minimum deviation is 2i minus A. So 2i is 2 times 45 degrees minus 60 degrees, so it will be 90 minus 60 equals to 30 degrees. So I know many of you struggle to solve numerical questions. So more you practice, better you will be for prepared for KCET. So if you are not practicing numerical questions, if you are skipping these videos, it will be very, very harmful for you. So don't skip, watch till the end, practice with me. Okay, if required, you can download the solution given in the description below. Practice from there as well as you wish, but you have to practice. Okay, if you are not practicing, you are actually ruining your own chances, right? Now question number 8. A convex lens of focal length L is placed somewhere in between an object and a screen. The distance between the object and the screen is x. If the numerical value of the magnification produced by the lens is m, okay, then the focal length of the lens is. So now let us look into the diagram first. We have a convex lens. Okay, there was an object and there is a screen. Okay, and the distance between them is given x. Okay, a lens is placed in between them. So only one lens that can be placed in between an object and the screen, that is a convex lens, right? Now it is mentioned that suppose this object distance is u, then the image distance will be x minus u. Obviously the magnification is given as m, right? Now if the object, in this case you know that if object is placed like that, then image will be formed in the opposite way, right? So m should be negative, and value of m is given by v by u. So minus m equals to v is x minus u, positive, and u is minus u, right? We always take u negative for left hand object is placed at left side, so this will cancel. So we can write x minus u equals to mu, okay, or x equals to mu plus u, or u equals to x divided by 1 plus m, or m plus 1. Let me write it m plus 1. Okay, so we have found u. Similarly, using this relationship, okay, I can find, we know v is x minus u, right? So I can put this value and I can find v as well. V is x minus x by m plus 1, right? So it will be m times x plus 1 times x, x minus x divided by m plus 1. So v is mx by m plus 1. Okay, so the only thing that is left is to apply the length equation and find the value of f, right? So we while again applying the length equation, we will again use the symbol signs. So don't forget, 1 by v minus 1 by u equals to 1 by f, right? So what is 1 by v? 1 by v will be, if this is v, then 1 by v will be m plus 1 divided by mx, and 1 by u, from there 1 by u will be equals to m plus 1 by x. Now u should be negative, right? We know that u should be negative, so 1 by v will be m plus 1 divided by mx minus m plus 1 by x equals to 1 by f. Okay, so just simplify this. M plus 1 by mx plus m plus 1 by x equals to 1 by f. Okay, so let's simplify. Let me take m plus 1 common. Okay, so mx plus 1 by x, LCM is mx, 1 plus m equals to 1 by f. So we can see that f is equals to mx divided by m plus 1 whole square, right? So m plus 1, 1 plus m plus 1 whole square, and now it was 1 by f. So if you reverse it, it will be mx divided by m plus 1 whole square. So let us look into the option, mx divided by m plus 1 whole square. So correct answer is option B. Okay. If you have any doubt, any question, you can mention that in the comment. Now, the power of an equiconvex lens is a minus 4.5D, and it is made of a material of refractive index 1.6. The radii of curvature of the lens is. So now what is the power? Power is 1 by f, where f is in meters, also in with the sign, right? So here we know that from lens maker's equation, 1 by f equals to n minus 1, 1 by r1 minus 1 by r2, right? Now for an equiconcave lens, if you remember, for equiconvex lens we have considered r1 equals to r, right? For equiconcave lens, r1 equals to minus r and r2 will be plus value, plus r. Okay, so we have to put these values here. So 1 by minus r minus 1 by plus r. So it will be n minus 1 minus 2 by r, right? So this is the focal length for a concave lens. So now we have to put the values. So 1 by f is given as 1 by f is directly given, that is minus 4.5. Right? Now remember that this is when focal length is in meters. So last stage we have to multiply with 100 to convert it into centimeter. So don't forget that. Okay, this is a very trick. So now 1 by f itself is given minus 4.5. So I will write minus 4.5 equals to n is given 1.6 minus 2 by r, minus minus cancels. So what we will do, 4.5 r equals to 0.6 times 2, that is 1.2. So value of R will be 1.2 by 4.5. Now this is, as I said, is in meters. Okay, this is in meters. So to convert it into centimeters, we have to multiply with 100, right? So this is in centimeters. So now let's simplify. Decimal gone. 3 4s are 12, 3 15s are 45. Okay, 3 5s are 15, 5 20s are 100. So it will be 80 divided by 3. Okay, so 80 divided by 3, 3 2s are 6, 2 20, 3 6 are 18, 20 again 20, it will be after decimal, it will come 26.6666. Okay, now this is a concave lens, right? So concave lens, the radii of curvature should be minus, so minus 26.6. Now it is for one surface it is minus, for one surface it is plus, but we consider the first surface excuse me, so we consider the first surface to be the primary surface. So for that, radius of curvature is negative, so we will use this as negative, and that will be minus 26.6. If plus and minus both are given, then you have to choose accordingly based on the which lens you are using. Now here only one negative value is given, so it is easy, right? Now let's move on. Next question. The refractive index from air to glass is 3/2, and that from air to water is 4/3. Then the ratio of focal length of a glass lens in water and in air. So it's a similar problem. Again, lens maker formula, very important for KCET if you are solving. So n to 1 minus 1. Now I am writing this. Now the nature of the lens is not mentioned, so we have to use like this only, R1 minus R2. Now when it is in air, the refractive index is 3/2 minus 1, 1 by R1 minus 1 by R2. Okay, so it will be half 1 by R1 minus 1 by R2. Similarly, when it is in water, this is in air. So when it is in water, it will be 3/2 divided by 4/3. As I know, the refractive index, the relative refractive index, the refractive index of the glass divided by refractive index of the water surrounding medium, right? Minus 1, 1 by R1. You can skip this writing everything every time, okay? Because only thing that matters is the refractive index, so you can skip that, but for sake of physics I am writing it. So it will be 9/8 minus 1, 1 by R1 minus 1 by R2. Nothing is there in R1 and R2, so you can skip writing that. So 1/8, 1 by R1 minus 1 by R2. So now if you divide this by this, then you will get F water by F air. Okay, so this will be cancelled. 1 by R1 minus 1 by R2 will be cancelled. So you will get 1/2 divided by 1/8. So 8/2, that is 4. So what they have said, water to air. So water to air is 1:4:1. Water to air is 4:1. So be careful what they have mentioned in water and in air. So water is first, air is second. So water is first, air is second, 4:1. If there was air to water, then it would have been 1:4. So be careful, okay, with this kind of questions, especially with ratio related questions. Okay. In refraction of light, waves are bent on passing from one medium to the second medium, because in the second medium the frequency is different, the speed is different, the coefficient of elasticity is different, the amplitude is smaller. Now you should remember that the light rays bend because they have difference in speed. I think I have explained while talking to this matter. So when light rays enter from one medium to another, the speed of light changes, that's why refractive index changes. Okay, so and frequency of a light is basically constant in any medium. Okay, frequency is the identity card of light. Okay, it will not change. It's like Aadhaar card of light. Okay, it will not change. It will always remain the same thing, right? Your date of birth, your phone number, your address will be written on that. So it will be like a permanent Aadhaar card. Okay, they even cannot change it. If for Aadhaar card, even if you want to update it, you can update it. But for light ray, it cannot be changed. Okay, so the frequency is different. That's why sorry, not frequency. Speed of light is different. That's why they change the direction. They bend it. So from one medium to another medium, the speed is different. That's why they bend. Okay. Now, two thin biconvex lenses have focal lengths f1 and f2. A third thin biconcave. So very careful while reading this question. Even though I will show you how you can solve it. Don't worry. So first two lenses are convex lenses. Okay, so focal lengths are positive. Okay, then the third lens is a biconcave lens. So the focal length f3 should be negative. Okay, a third thin biconcave lens has focal length of f3. If two biconvex lenses are in contact, the total power of the lenses is P1. If the first lens, convex lens, is in contact with the third lens, the total power is P2, and the second lens is in contact with the third lens, the total power is P3. Okay, then what will be the case? So first we have two convex lenses and one concave lens. So first simplify this problem. This is a very huge long problem. Focal length f1, f2, f3. Okay, this will be minus. Now we know that when two lenses are in contact, first case, these two lenses are in contact. So when these two lenses are in contact, the power is P1. Power is P1. We know that power is P1 is equal to say this is P01 plus P02, right? We have learned this formula. So P01 is nothing but 1 by F1 and P02 is nothing but 1 by F2. So it will be F1 plus F2 divided by F1 F2. Now if you see in the options, only one option has correct for P1. Okay, all other options are incorrect for P1. So basically you can write your answer closing your eyes. Okay, as long as you have done it correctly, and if you are still in doubt, you can do it for the second lens as well. So how can you do it for second lens? So now this lens and this lens are in contact. So case 2, power 2. Power 2 is P01 plus P03, right? So P01 is 1 by F1 plus P03 is minus F3, right? Concave lens, so focal length should be negative. So if you add them, you will get F1, F3. So F3 will be here minus F1. Okay, again if you calculate the P3, it will be F3 minus F2 by F2 F3. Okay, similarly, because in this case F1 was convex, so convex was minus, here F2 is convex, so it will be minus, and the pattern you can follow. So from there you can see that all other things are matching. So the correct answer should be D. Okay, and for that you don't need to calculate everything. First relation itself is sufficient. Okay, the first relation itself is sufficient and you can solve it without even bothering about other two options. Okay, now let's move on. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 centimeter is 2 centimeter. Okay, so the size of the image of an object, let us break down this question slowly. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 centimeter is 2 centimeter. Even though the object is at infinity, it should produce a point object, but for a hypothetical case, for a hypothetical case, let's assume that the size of the object image is 2 centimeter. Okay, even though the object is an infinity, the image formed by it is 2 centimeter. If a concave lens of focal length 20 centimeter is placed between the convex lens and the image at a distance 26 centimeter from the lens, then the new size of the image is. So first of all, we have to understand the question. We know that a convex lens, when parallel rays of light, that is from infinity, falls on it, where does it focus? It focuses on the focus itself, right? So if the focal length is 30 centimeter, then the image distance in this case will be 30 centimeter, right? Now what is happening here? You are placing a concave lens between the lenses. Okay, so this distance was 30 centimeter and this distance is 26 centimeter. Okay, so now you are being asked where the final image will be formed. Final image will be formed somewhere here, suppose. Okay, now this is a special case. I don't want to go into the details of this is a virtual object, real image is being formed. So I am not going to detail. We are just going to use the formula and solve this problem. So now we only need to consider the concave lens and the object distance, and we should find the image distance. Now if you observe that in this case everything is happening on our right hand side, so object distance will be positive in this case. Very special case. So now what is the object distance? This is the object distance. So what is the object distance? U will be 30 minus 26, that is equals to 4 centimeter. Okay, and it is positive because it is on the right hand side. Right, now we know that 1 by V minus 1 by U equals to 1 by F. Okay, the focal length of the concave lens is 20 centimeter. We know that focal length of a concave lens is negative. So 1 by V minus 1 by 4, okay, is equal to minus 1 by 20. Concave lens focal length is negative. So now what we will do, we will simplify it a little bit more. 1 by V equals to 1 by 4 minus 1 by 20, right? So 1 by 4 will go to the right hand side, become positive. Minus 1 by 20 was already there. So now 1 by V, what is the LCM? LCM is 20, right? LCM is 20. So 5 4s are 20. 5 4s are 20 and 20 is already there, so minus 1. So 4 by 20. 5. So V equals to 5 centimeter. Okay. Now what is the, they have asked you what is the size, new size of the object. Okay, so object distance, final image distance is not yet, the solution is not yet done. So the magnification is V by U. Magnification is V by U. V is 5, U is 4, right? So this is the magnification, and original size was 2 centimeter. So the final size will be original size times the magnification. So it will be 2.5 centimeter. Okay, so 2.5 centimeter is the new size, right? Interesting question. So basically we can see that a concave lens is producing a magnified image. This is a very special case. Sometimes it is possible, so don't get confused if you get this kind of problem where you are seeing, okay, concave lens is producing a magnified image, it should be wrong. No, it is possible. Sometimes it is possible. Now the refracting angle of a prism is A, and the refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is, I think I solved this question while doing our regular classes. If you missed there, don't miss it here. We know that refractive index is given by sine A plus delta m, that is minimum angle of deviation, by 2 by sine A by 2. Right? Now this is given as cot A by 2. Refractive index itself is given by cot A by 2. Now what is cot A by 2? Cot A by 2 is cos A by 2 by sine A by 2. Right? We know that. Now sine A by 2 can cancel. They are not zeros. So if they are zeros, then it will be the equation has no meaning. So we can write sine A plus delta m by 2 equals to cos A by 2. Now cos A by 2 can be written as sine pi by 2 minus A by 2. Right? Cos theta is sine pi by 2 minus theta. Right? Complementary angles. So from there we can take the sine inverse on both sides. Sine will cancel. So we can write A plus delta m by 2 equals to pi by 2 minus A by 2. So these 2's all, every side has 2. So I can cancel to multiply 2 with every side. So it will become A plus delta m equals to pi minus A. Right? Or delta m equals to pi minus 2a. Now what is pi? All the answers are given in degrees. So pi means 180 degrees. Don't get confused. Here we are converting radian to degrees. So 180 degrees. 180 degrees, sorry, not 3a. 180 degree minus 2a. Okay. So 180 degrees minus 2a is the answer. Simple question, simple problem, interesting problem. Okay, very, very interesting problem. An object approaches a convergent lens from the left of the lens with a uniform speed of 5 meter per second and stops at the focus. Then what will happen to the image? Okay, now you should remember that object is approaching from the left with a 5 meter per second speed. As soon as it reaches the focus, okay, before it reaches the focus, the object, the image was forming somewhere at a measurable distance. But as soon as it reaches the focus, the final image is now formed at infinity. Okay, so from finite to infinite, this is completely non-uniform. Okay, there is no relationship between finite and infinite. So it is suddenly the distance increases a lot. Okay, a huge margin, and there is no such relationship. So we can say that the moves away from the lens with a non-uniform acceleration. So we can say that the object is moving with a non-uniform acceleration, obviously. Okay, so when the object was, say, suppose at 2f, okay, there was some acceleration, but as soon as it reaches f, the final image is now at infinity. So at infinity means the acceleration should be not uniform. Now this is also a very interesting question. The following figure shows a beam of light converging at a point P. When the concave lens of focal length 16 centimeter is introduced at the path of the beam at the place shown by the dotted line such that the OP becomes the axis of the lens, then the beam converges at a distance x from the lens. The value of the x will be. So what they have done, the rays were converging at P when nothing was there. Now they have introduced a concave lens. Okay, now the rays will be converging at some point further ahead. So that distance will be x. What we have to do, we have to find that x distance. Okay, so the formula, we know that 1 by v minus 1 by u equals to 1 by f. Okay, now what are all the values given? Focal length is given 16 centimeter. For a concave lens, focal length is negative, right? And the initial distance is 12 centimeter, and because it is on the right hand side of the lens, the object distance will be positive, right? So object distance will be positive. So 1 by v minus 1 by 12 equals to 1 by minus 16, right? So focal length of convex lens is concave lens is always negative. So 1 by 12 minus 1 by 16. If you remember our previous problem, this kind of problem is also very common in KCET. So the LCM will be I think 48. Okay, 4 12s are 48 minus 3 16s are 48. So it will be 1 by 48. Right. So V will be 48 centimeter. So this is the value of X. This is the value of the X. So from the option we can see correct option is option B, right? A certain prism is found to produce a minimum deviation of 38 degrees. So minimum deviation of 38 degrees means delta M is given 38 degrees. Okay. It produces a deviation of 44 degree when the angle of incidence is either 42 or 62. What is the angle of incidence in the undergoing minimum deviation? Now we know that for any other angle of deviation is given by I plus E minus A, right? This is the formula. Now here they have mentioned incidence is either 42 or 62. Either or means if 42 is angle of incidence, then 62 will be angle of emergence, and if 62 is the angle of incidence, 42 will be the angle of emergence, right? We know that for each value of I, we get two values. One is incident. If one is incident, then other one will be emergent, and if the other one is first one is incident, the second one will be emergent, right? So they are changing, they can change their places. So only thing we need to do 42 plus 62, right, minus A, and that angle of deviation is given 44 degrees. Okay, so what is A? A is given by 42 minus 62 is 104, 42 plus 62 minus 44. So this A comes to the left hand side, this 44 comes to the right hand side. So it will become 60 degrees. Okay, so they have asked you to find the what is the angle of incidence for minimum deviation. Now for minimum deviation we know that delta M is given by 2I minus A, because angle of incidence and emergent both are same. So this is given as 38 degrees minus equals to 2I minus 60 degrees, right? So this will come on the other side. So we write 2I equals to 38 plus 60, that is 98 degrees, right? So I equals to 49 degrees. So angle of incidence will be 49 degrees. Okay, if you have any questions, any doubt regarding any of the questions that we are going to solve, you are solving today, please mention in the comment below. So we have crossed the halfway point. Now we are at the question number 17. A point object is moving uniformly towards the pole of the concave mirror of focal length 25 centimeter along its axis as shown. The speed of the object is 1 meter per second at t equals to 0. The distance of the object from the mirror is 50 centimeter. The average velocity of the image formed by the mirror between t is equal to 0 and t is equal to 0.25 is. So now at the beginning the speed of the object is 1 meter per second, right, at t equals to 0, and object distance is 50 centimeter, right. The average velocity of the image formed by the mirror between t is equal to 0 when the object was at 50 centimeter. At the beginning the object was at 50 centimeter. Okay, now if you see the focal length is also 25 centimeter. So basically the object was at 2f, that is at radius of curvature. If the object is at radius of curvature, then the image will be also at radius of curvature at the beginning. Understand this point. So at the beginning the object is at radius of curvature, image is also at the radius of curvature, and the object is moving towards the mirror. So after some time it reaches here. Okay, so now what is the position of the image after this 0.25 second? That is what we are interested in. Okay, right, so that is what we are interested in. So let us first find the displacement from the speed given. So we know that s equals to vt. Okay, so v is 1 meter per second, time is 0.25 second, so the distance is 0.25 meters. Okay, 0.25 meters, that is 25 centimeters. So the object moved a distance 25 centimeter in that 0.25 second. So 25 centimeter means where the object is now. So object has moved to 25 centimeter. So 25 centimeter means, if you read the questions carefully, the object should be at focus of the mirror. Okay, so the object is now at focus. After 0.25 second, the object reached the focus. Now when the object is at focus for a concave mirror, where is the image formed? The image formed will be at infinity. If you remember, image formed will be at infinity. So they will all go there. So it will be formed at infinity. Okay, these two rays will be parallel. So object image will be formed at infinity. So object is at focus. The image moved from R to infinity in 0.25 seconds. So what is the speed from R till infinity in 0.25 seconds? Then the speed should definitely be infinity, right? Because the image is at infinity and this happened in a very small amount of time, the speed should be definitely be infinity. So the correct answer is option C. This is also a very interesting question. This type of questions does not require too much mathematics. You should understand that when they are talking about speeds, object is moving, accelerating, this type of problems does not require too much mathematics. Only thing that you have to do is the critical thinking. You have to answer this question with reasoning. So if you have a clear reasoning, you can answer this kind of questions. Now, an object is placed at a distance of 20 centimeter from the pole of a concave mirror. Of focal length 10 centimeter, the distance of the image from image formed is. So, distance is 20 centimeter, focal length is 10 centimeter, and it is a concave mirror. Okay, so concave mirror means object is here. Okay, you placed it at 20 centimeter, focal length is 10 centimeter. So what is the distance? Distance is obviously 2f, that is equals to r. So in that case, image will be formed at r. But which side it is formed? It formed on the left hand side. So left hand side means image distance definitely will be negative. So be careful. This is only to test if you know the sign convention or not. Otherwise, this is a very simple question, right? 1 minute question or less than 1 minute question, 10-second question, right? Let's move on. A candle placed 20, and in case of you are having difficulty while answering ray optics question, I have a suggestion for all ray optics questions. Try to draw the diagram if possible. If you understand the question, fine. If you don't understand the question, read the question, draw the ray diagrams, then it will be easier for you to answer these questions. A candle placed 25 centimeter from a lens forms an image on a screen placed 75 centimeter on the other side of the lens. So let us draw the diagram. We have a concave lens. Okay, a candle placed 25 centimeter. Okay, this distance u is 25 centimeter. Okay, image on a screen placed on a other side. So image is formed on the other side at a distance 75 centimeter. It will be obviously inverted. Okay, obviously inverted because real images are always inverted. The focal length and the type of the lens. So obviously it will be a convex lens because for concave lens the image is formed on the same size as the object, right? If you remember yesterday's table. And for convex lens, if the distance is greater than focal length, the image will be formed on the other side of the lens, right? So let us find the focal length. We know that 1 by v minus 1 by u equals to 1 by f. So 1 by v is 75, it is positive because it is on the right hand side. 1 by u is negative because it is on the left hand side. That is equals to 1 by f. So 1 by f equals to 1 by 75 plus 1 by 25. So it will be 75, 1 plus 3. So 4 by 75. So F will be 75 divided by 4. Okay. So it will be around 18. Okay. Around 18. So around 18, how can I say it is around 18? Because if it is 20, then it would have been 80, right? If the numerator was 80, then it would have been a full number 20. And what is less than 4? So 80 minus 4 is 76. So 76 means it would have been 19, right? But it is neither 76 nor 80, it is 75. So it should be very close to 19 but less than 19. So 18 is the closest number. And if you see the options, 18 and convex lens, right? So we have already identified the type of lens already. So only thing that was left is to find the focal length. So it is 18. Clear? Now, during the scattering of light, the amount of scattering is now deleted from your syllabus. So the correct answer is 4th power. So I am not going to explain anything about scattering. Okay, Rayleigh scattering is no longer part of your syllabus. Okay, so it was previously there, Rayleigh scattering, then resolution power, but those are not in syllabus anymore. A linear object of height 10 centimeter is kept in front of a concave mirror of radius of curvature 15 centimeter at a distance of 10 centimeter. The image formed is, so what is the question? A linear object of height 10 centimeter is kept in front of a concave mirror. So concave mirror, so it can be real, virtual, everything is possible, right? Radius of curvature is given, R is given 15. So R is 15 means F will be 7.5, right? At a distance of 10 cm. So distance is 10 centimeter. So object is placed at here, 10 centimeter. So it should be between R and F, right? Now the image formed. So the type of image, obviously it is between R and F. So the image will be definitely real and inverted. And because it is between R and F, the image will be magnified. We said that when the object starts at infinity and if you start walking towards the mirror, initially you will get a small image at the focus. As you are approaching the mirror, the size of the image will be start increasing. As soon as you reach R, the size of the image and object will be same. And if you cross R and if you moving towards the mirror, okay, the image size will start increasing. Okay, so it will be magnified and inverted because it is a real image, so it has to be inverted and magnified. Okay, a plain glass plate is placed over a various colored letters, violet, green, yellow, red, the letter which appears to be raised more. So I gave the explanation that refractive index is inversely proportional to the wavelength. Okay, and more the refractive index, okay, higher amount it will raise. So for this we can see that violet has the least wavelength among these all the colors. So violet will have the highest refractive index. So highest refractive index means more rays. So violet will rise more compared to red, yellow and green. Okay. A ray of light passes through 4 transparent media with refractive indices N1, N2, N3 and N4 as shown in the surface. All of the media are parallel if the emergent ray DE is parallel to the incident ray AB. So what is the question? This ray AB and this ray DE are parallel to each other. Then they have asked you which of the following relationship is correct. Now I explained that this ray and this ray are parallel means only when it is possible that this refractive index and this refractive index are equal. Okay, so N1 must be equals to N4. This is the only case when this is possible. In between how many medium you keep does not matter. Okay, there was a derivation, but that derivation is no longer part of the syllabus. In between if you keep n number of materials does not matter as long as first and the last medium are same, that is they have the same refractive index, then these final initial ray and the final ray will be parallel to each other, right? So the correct answer is N1 is equals to N4. Okay, final and initial. Okay, now focal length of a convex lens is 20 centimeter and its refractive index is 1.5. It produces an erect enlarged image if the distance of the object from the lens is, so focal length of the convex lens is 20 centimeter, focal length is 20 centimeter, refractive index does not matter, okay. It produces an erect enlarged image. So when a convex lens produces erect and enlarged image, remember that spyglass, yes, when the distance is less than the focal length. If the distance is less than the focal length, it produces enlarged and erect image. So from the given option, if you see 40 centimeter, 30 centimeter, 20 centimeter, they are all either equals to focal length or greater than focal length. Only one is less than focal length. So when the object is at 15 centimeter, it will be erect as well as magnified and virtual. Okay. A ray of light suffers some minimum deviation when the incident on a equilateral prism of refractive index √2. The angle of incidence is. So equilateral prism. So equilateral prism, I will already explain equilateral prism. The angle of prism is 60 degrees, and we know that refractive index is given by sine A plus delta by 2 by sine A by 2, right. So refractive index itself is given √2 sine 60 plus delta m by 2 by sine 60 by 2. So sine 60 plus delta m by 2 equals to √2 sine 60 by 2 sine 30 degrees. So sine 30 degrees, what is the value of sine 30 degrees? Half. So it will be 1 by √2. Now what is 1 by √2? 1 by √2 is sine 45 degrees. So if you take sine inverse on both sides, you will get 60 plus delta m by 2 equals to 45 degrees, or 60 plus delta m equals to 90 degrees, or delta m equals to 30 degrees. Okay. So the correct answer is option A. Right? Clear? Next question. Calculate the focal length of a reading glass of a person if his distance from the distinct vision is 75 centimeter. This is also very interesting question. So the object is you need a convex lens to correct this error, right? Hypermetropia. So the normal distinct vision is generally 25 centimeter. So when the object is at 25 centimeter, this lens has to adjust the distance such that final image is formed at 75 centimeter from the lens, right? So what we have to do, you have to use the formula 1 by v minus 1 by u equals to 1 by f. Okay, so if I want to correct it, u should be minus 25, that is here, okay, and after refraction it should appear to come from 75 centimeter. We know convex lens can produce virtual images also, right? So v should be equals to minus 75. Okay, so let us put these values. Minus 1 by 75 minus 1 by minus 25, this should be equals to the focal length. So minus minus plus 1 by 25 minus 1 by 75 equals to 1 by f. Okay, so it will be 75 3 minus 1 equals to 1 by f. So it will be 2 by 75 equals to 1 by f. So f equals to 75 by 2, that is 37.5. Okay, so the correct answer is 37.5. Okay, simple problem, but only thing that you have to understand is what is the minimum angle of minimum distance of vision. Minimum distance of vision is if an object is placed close to your eye, okay, the minimum distance from where you can see it clearly. That distance for a normal human eye is 25 centimeter. But because of its eye lenses are no longer able to see the object close, now he is seeing any object up to 75 degrees, 75 centimeter. Okay, if you bring it closer than that, then it will not be able to see it. So what I can do, I have to place a convex lens which makes that object which is at 25 centimeter looks like it is at 75 centimeter. So that the normal the people with that glass can see that object clearly. Okay, so that is being done using a convex lens where it is forming a virtual image. Okay, now let's move on. A person wants a real image of his own 3 times enlarged. Where should he stand in front of the concave mirror of radius of curvature 30 centimeter? So what is the given data? So we have a concave mirror, okay, then there is a object. He wants a 3 times enlarged real image, right? So 3 times enlarged, suppose the object is here, he wants a 3 times enlarged real image. Okay, so real images are always inverted. You should remember that real images are always inverted. So if this is U, then this is V, both of them are on the left hand side of the origin. Okay, so both should be negative. Also, because the image is inverted, then the magnification should also be negative. And focal length is here somewhere. So focal length will also be negative, right? So what is the focal length? Focal length is r by 2, that is minus 30 by 2, that is minus 15 centimeter, right? So the focal length is minus 15 centimeter. Also, the magnification is given 3 times. 3 times means magnification is minus 3. Because it is inverted, the magnification has to be minus 3 because real image. So that should be equals to a minus V minus U. Sorry. Now magnification in case of a mirror is given by V by U minus V by U. Okay, both of them are negative, so negative will cancel. You can put the signs of V and U also here, but they will cancel. Okay, and then there is a default negative sign for magnification in case of mirrors. Okay, so these negatives will be cancelled with this. So we can write V equals to 3U. Okay, from this relationship, clear? V equals to 3U. Now what is the mirror equation? 1 by V plus 1 by U equals to 1 by F. Now V is itself negative, V is negative and its value is 3U, U is also negative and F is also negative, right? So now all the negative signs will be common and they will cancel each other. Okay, so what we will write is 3U, the LCM is 3U, it will be 1 plus only U was there, so 3 will be here, so it will be 1 by 15. Okay, so 1 plus 3 is 4, 4 by 3U equals to 1 by 15. Okay, so we can do the cross multiplication. 3U equals to 4 times 15, that is 60, or we can simply cancel 3 5s are 15, 4 5s are 20 centimeter. So U is 20 centimeter. Correct answer is option B. Correct. If epsilon naught and mu naught are the permittivity and permeability of free space and epsilon and mu are the corresponding quantities for a medium, then refractive index of the medium is. We know that first of all speed of light in vacuum is 1 by square root of mu naught epsilon naught. Last chapter we have learned that, and for any other medium speed is 1 by square root of mu epsilon, right? Also refractive index of any medium is speed of light in vacuum divided by speed of light in that media. So it will be 1 by square root of mu naught epsilon naught divided by 1 by square root of mu epsilon. So mu epsilon will be go up. So mu epsilon divided by mu naught epsilon naught. Okay. So the correct answer is option A here. Okay. I guess this is the last question of the day. So those who are all waiting, this is going to be the last question. An object is placed at 20 centimeter in front of a concave mirror, produces 3 times magnified real image. What is the focal length of the concave mirror? Same question that we have solved 2 problems ago, only the value of the focal length is different. Okay. Focal length is not different. In fact, if you see that question, okay, where we have solved it, so we received the u 20 centimeter, focal length was 15 centimeter, right? So focal length was 15 centimeter, u was 20 centimeter, magnification was 3. Now the same question is asked. Okay, here they have given you u and they have asked you find f. So f will be 15 centimeter. Using the same calculation, m is minus 3 equals to u by v minus v by u. Okay, using the same calculation you can solve it and you will get the answer to be 15 centimeter. I am not doing everything, I am just giving you a hint. Okay, so v equals to 3u and then you have to use 1 by v minus 1 plus 1 by u equals to 1 by f. Okay, and it will come out to be a minus 15. Okay, but they have only asked you the magnitude, so it will be 15 centimeter anyway. Okay, so we have completed today's lecture. If you have any doubt, any question, don't forget to mention that in the comment. And if you have liked this video, don't forget to click it on the like button and share it with your friends. Subscribe to our channel. Thank you. I will be back with a new video tomorrow.